Hello, my name is Shailesh Kharche and I will start the presentation on implementing soft sensing techniques like neural networks in NIR spectroscopy. NIR spectroscopy basically involves detecting the presence of compound depending upon its infrared wavelength absorbing capacity. But this field in analytical was always pulled back due to the huge amount of data generated. But as we know, neural network can handle this kind of huge data very easily. So this case project involves how the neural network's capability and the disadvantages of NIR is merged to get some very good results. So this is the overview of a complete process. We have unknown sample which is processed, which is scanned through FTNIR analyzer. We get a wave we get this kind of waveform, which is a waveform of wave number versus the amplitude. To process this data, we have to first import it in MATLAB. We create a data sets. From that we give this data set to the neural network to train the neural network, and this neural network, depending upon the training data set, will give how what kind of will give the contents of the unknown sample when the input is given to it. So let's see how it works. Data processing. In data processing, since we have used alcohol for our complete case project because we were not, due to the corona situation, we were not able to get water sample on different locations. But the same techniques can be applied for any compound or any samples. So in total we got 352 readings, and which includes ethanol sample from 1 to 60% and different alcohol liquors. This is the waveform which we got from these samples. Now to train the neural network, we have formed two data sets. One data set includes the wave number, and the other one data set includes the wave number at the amplitude, and the other dataset includes the corresponding alcohol percentage of that sample. Like for the first one, this is the amplitude plot of a sample, and this is the alcohol percentage in that sample. This whole case project is divided into two parts, classification and regression. We have first done classification to classify samples depending upon the alcohol percentage. We have classified using this. Less than 8% it will go into beer category, less than 25 it will go into spirit, and less than 100 it will go into disinfectant. These are the plots we got after the training neural networks, and we got very good results. Every input samples is classified. We got 100%, and every sample was confined to the particular category depending upon the alcohol percentage. This is performing plot and receiver operator characteristics plots. This is the classification result which was given by the trained neural network. To show the result properly, we have formed a single table from the neural network output. The first column shows the alcohol percentage of that sample. The second three columns, 2, 3, 4 columns are the classification done by the neural network, and 5, 6, 7 are the output of the neural network function, according to which the classification of the input sample was done. So we can see from the results how properly and accurately the neural network classified it. First, like 1, 2, 3 are 5% alcohol, and it was able to classify it in the first group, which was the beer group, and the next readings were 40% alcohol, and it classified it as a disinfectant. So classification was done very properly by the neural networks. And now my friend Amir will give presentation on regression, like what kind of how the neural networks are properly able to identify alcohol percentage in an unknown sample.
Hi, my name is Amir, and I want to continue Silish talk. As Silish explained, the project should be done actually for water quality purpose, but because of this corona pandemic, it was impossible for us to go to lab and gather measurements from water samples of different quality factors and so on. That was why we use some data that we have gathered for another project. I have to mention that in that project, the focus was on detecting the amount of alcohol in different alcoholic drinks. We had 40 samples of wines, beers, whiskeys, vodkas, and something like this. Uh, but we think that maybe these samples are not enough. And another reason was that we didn't have some specific amount of alcohol. For example, you cannot find alcoholic drink with 19% of alcohol. It's very difficult to find something like that. So we decided to mix water and ethanol to make more samples with actually all the concentration we wanted to. So we came up with 60 samples of water and ethanol mixture with alcohol concentration of 1 to 60% of alcohol, and adding them to our previous samples of drinks, we finally had 100 samples in hand. Um and I just want to add something more. Uh, we knew that maybe our measurements are not perfect, so we repeated our measurements for each sample at least 3 times, for some of them 5 times, and for another ones maybe 20 times. So we had lots of measurements. Then we just dropped some of them that was not good. We understand that this measurement is not good, so we just put it away. So how can we use whatever we have done here? How can we apply them to the water quality purpose? Okay, we Salish talk about the classification, and we can afterward with real water samples we can classify samples into clean or non-clean water, for example, or drinking or non-drinking waters, or for example from the origin of the water, seawater, well water, river water. We can classify them like this, so it can easily be applied in water quality purpose. And for what I want to explain later, the regression, we also can, instead of predicting the amount of alcohol, we can predict the amount of pH of water, or nitrogen, or phosphorus, or salt, or chlorophyll, or etc. Anything. We can just predict these things in a water sample. These are somehow the quality factor of a water. So let's focus on what we did exactly. We use uh, the samples in our neural network training phase, and we put some of them, which was actually the most of the uh, drinks samples. So we use all of the mixture of water and ethanol in our training set, and some of the drinks in our training set as well. But our test set only contains the some of the drinks, the remaining drinks. So we did like that. And um, so uh, the difference between this part and the part Salish explained is that in this part the input vector was the same, but the output vector was just a number, and that number was the amount of alcohol in that sample. As you can see, after training uh, the network, uh, we come up with 10 to the minus of 1 error. So it has a very good performance, good enough, I mean. So yeah, this is what we get from the train, and we applied the trained neural network on our remaining samples. And what we get was interesting. We can predict the amount of alcohol. As you can see, this is the uh, regression line, and this, yeah, it's difficult to see, but this uh, gray line is the line of 100% accuracy. So the blue and the um, gray line are somehow the same. So the network is working very well in predicting the amount of alcohol in our drinks. So here we can see it in more details. If you just take a short look here, for example, a drink that contains 47% of alcohol predicted as 46.2, which is, yeah, good enough. Uh, and 37.5 predicted as 38.5. Yeah, just a little more than 1% error, but it's good enough. And I have to just mention two things. We have two samples, one here and one here. Yeah, you see three measurements of each one. And this sample, I knew before that it's some kind of wine, by some kind of beer, but I didn't know the exact amount of alcohol. As you can see here, it's predict 4.4, 4.4, 4.2, which is, yeah, I can uh, accept it, because any beer is has some kind of alcohol, about 3 to 5, 6% of alcohol. So it's good. It's okay. And we have another sample, which was a cocktail given to me by a barkeeper. He made it himself, and he asked me to tell him how much alcohol does it contain. And now I can tell him that it contains something around 30.7% of alcohol, and I can rely on this number. If it, yeah, maybe less than 1%, it's accurate. So that's the regression part of the uh, our project, and Silish will continue the talk by introducing some modules we prepare in uh, uh, MATLAB Simulink. Thank you very much.
To demonstrate the result of our case project properly, we have made a Simulink model. In that model, we have used the two neural networks which were trained earlier. We will give 5 different inputs to that neural networks depending upon the knobs. These inputs are completely random inputs which are taken from our readings. We know the alcohol percentage of these inputs, but this neural network don't know this. And depending upon this input, our neural networks will be able to classify that input sample according to the alcohol percentage. So this neural network is the regression neural network which will determine the alcohol percentage, and this neural network will classify that input sample depending upon the classification model. So let's see it in running. I will just run it. Now currently I have given input 5. So you can see that how accurately our neural network is able to predict the alcohol percentage, and depending upon that it is also able to properly classify this sample as a spirit. Now I will give different input. Now I have given input 4 to this neural network, and we can see it has given 19.8% alcohol, and also it classified as a spirit. The results we got are very accurate. We know that the input 4 is 20%. So our neural network is properly able to predict the values depending upon its training. So it's very accurate. It's 20% and this network is showing 19.8. Now I will give input 3% alcohol, and it is also able to properly classify it as a disinfectant. Input 2. This is the beer sample. We know it is a beer sample, and beer samples are usually 4.5%. So it you can see the accuracy with which this neural network is able to identify the alcohol present in that sample and also classify it as a spirit. So the results we got are very promising. We can use these similar techniques in detecting water quality also, and we can see how the soft sensing techniques greatly helps in doing more analysis on the NIR spectra which we get from NIR spectroscopy. Thank you. Thank you very much. I especially want to thank Professor Hekon and Professor Sabha for guiding us in this case project. Thank you.